Okay, hi guys, this is your second video for this week. This is the very end of section 5.5. So on Monday, I made a video for you about solving log equations using method 1. So hopefully you did okay with that first video, and the worksheet and answer key are all posted for you. Today, I just want to take a few minutes and walk you through the method 2, which is if you do not have logarithms on both sides, you want to first get the logarithm by itself and then rewrite the log expression as an exponential. So I have these relationships back up here at the top of the page again because our problems are going to originally look like this because they're logarithmic equations, and we're going to rewrite them, finding the base, raising that base to a power, and setting it equal to what we originally had over here next to the log. These are a little harder than the ones that you were working on Monday, but still not too difficult. So the first four that we're going to do, the logarithm is already by itself, so we don't need to worry about that first step. So we'll do the easier ones first, and then as we get to the bottom of the page, you'll see that we may have a little extra work to do. So on this first one, we'll jump right in. We want to rewrite this. We can see that it's logarithmic because we have a log right here on the left-hand side. You want to first identify your base, and the base here is 5. So you can see up here, we're going to write that base, raise it to the power, the value that sits on the other side of the logarithm. So that would be a 2. And then it's equal to whatever argument was sitting here originally. So you guys practiced this earlier in chapter 5, where you were kind of just rewriting from logarithmic to exponential and vice versa. The reason we did that is to kind of primer you and get you ready for solving these types of equations. So now we know that 5 squared is 25. And we can go ahead and solve that using algebra skills. Move the 1 over here. Divide both sides by 3. And we have x equals 8 as our answer there. Okay, let's look at another one. So for this next one, again, we want to always make sure this logarithm is sitting by itself, which it is. So you don't have to worry about that. Then we're going to rewrite using this relationship here up at the top. So our base this time is 4, it's raised to the second power, and it's equal to x plus 3. So from there, it's just a nice, easy algebra problem. So it's 16 equals x plus 3. You finally move that 3 over to the other side using subtraction, and your final answer is x equals 13. Now with all of these, you also want to still make sure that this argument that's sitting in here is always greater than 0. For all of these examples, everything works out fine. For instance, if we put an 8 in here, 3 times 8 is 24 plus 1 is 25. So we're fine here. We don't have any answers that are going to cause us any problems. But you do need to always keep that in mind. Okay, let's move down. So our next two that we have, the first one might look a little different to you. I know some of you had some issues on a problem that was similar to this on an earlier worksheet. But when you see this ln here, the base for that is lowercase e. Okay, whereas here the base is 3, it's written out as a 3. But when you see this ln, it's like there's a little tiny e here that doesn't ever get written. So when we start this problem, we know that the base is e, so we start with that on the left-hand side. And we're going to raise it to the 4th power, because that's what we see over there, and it's equal to 7x plus 9. Okay? So now we need a calculator, because e to the 4th is going to be a decimal value. So if you have the small blue calculator, you want to find your button that has e raised to a power, which is right here above ln. I don't know how well you can see it on the video, but so what you want to do is you want to hit second ln, and you'll see that e with a caret next to it. That means you're raising e to some number. We want to know what e to the 4th is. So we're going to type in e right in there, and we're going to get 54.598. It's fine if you just want to use one decimal point there. So 54.6 is what we have on the left-hand side with our calculator. And then we have 7x plus 9 on the right. So from here, again, it's just a little bit of algebra. You're going to move the 9 over here using subtraction. So we're going to end up with 45.6 equals 7x. And then you divide both sides by 7 and end up with 6.5. And that's fine to have a decimal as an answer. So these, I think there's one or two of these on the sheet that I gave you, which is worksheet 2 for this week. The answer key is also posted for you. Okay, next one, again, logarithm is already by itself. We're in good shape there. Let's find our base. It's 3. What's the power that it's being raised to? It's over here on the right-hand side, so we're going to go 3 to the 4th power equals, what is it equal to? Whatever the argument of the logarithm was in the original problem. So nice and easy, that's set up for us. If you don't know what 3 to the 4th power is, off the top of your head, that's fine. You can use your calculator to get there. So you're going to go 3, and then you're going to put the caret in there and raise that to the 4th power. And that's going to give you 81. And then from there, you can just continue with your algebra, move the 1 over using addition. 82 equals 5x. And then you can divide and change that into a decimal. And that's just fine. It's going to be 16.4. So that's those two. This one just had a little bit of a trick in it because you have to remember that ln goes with the base e. Okay, so then the last two that I want to talk about, you'll see that I have them starred. And that is because they require one extra step. So let me just shuffle down so that you can see all of that. And then, okay, so let's work on these. Again, they have one extra step to them. So you'll see here, we have a logarithm here, but it's not by itself. This expression, here's my red pen. This expression right here, log base 7 of 6x, is being multiplied by 2. So we need to clear that 2 out of there before we can do anything else. So we're going to divide both sides by 2. Because it's being multiplied, the opposite of multiplication is division, so we're going to divide. So on the left, we now have log base 7 of 6x equals negative 2. Now from here, it's going to look just like the problems up above, where you start with your base, raise it to the power that's on the other side, set it equal to the argument. Okay, so here you have a couple of options. I'll do it both ways for you. But you should be remembering by now that when you raise something to a negative power, that puts this value in the denominator. So this is really 1 over 7 squared equals 6x. 7 squared is 49. You can leave it just like that. And then when we divide 6 on both sides, you really have 49 times 6 now in the denominator, because dividing by 6 is the same as multiplying by 1/6. So when you do 49 times 6 in your calculator, you get 294. So it's fine if you want to do it that way. You could also, at that point, put 7 to the minus 2 in your calculator and see what that is as a decimal. So 7 raised to the, make sure you use this negative symbol down here, negative 2. And it's 0.0204. Which is what 1 over 49 is. And now we can divide both sides by 6, and you have that 0.0204 divided by 6, and you get 0.0034 as your answer. Which you'll see if you also take a look at 1 divided by 294, that's also 0.0034. So either way you want to do it is fine. Just be ready to do it, both ways, because your quiz on Friday will be multiple choice. So if you see an answer like this and you've done it like this, you have to know that maybe you should have walked through it in a different way to get the fractional answer instead. Okay. Okay, so just one more. Let's take a look at right over here. So here again, we have log base 3 of x minus 8. It's not by itself, it's being multiplied by negative 10. So we are going to divide both sides by negative 10 because the opposite of multiplication is division. So when we do that, we end up on the left with log base 3 of x minus 8 equals 2. And from here, it becomes very similar to the problems up above, where we have 3, here's our base, raised to the power that sits on the other side, equals x minus 8. 3 squared is 9. Move the 8 over, and our final answer is x equals 17. So So that one was more straightforward because it didn't have the negative. Anytime you have a negative over here, you're going to have fractional amounts as your answer. This one was a little bit more straightforward. So those are the two things that I wanted you to be aware of for today. Again, remember that for this second method here that we're talking about now, you need to make sure that you know or have written down this transfer between logarithmic and exponential equations. So this particular video was all about method 2. You can now take a look at worksheet 2, which also has an answer key posted. Today's Wednesday, so make sure that you're looking at those this afternoon at 1 o'clock. I'll be on conference. If anybody wants to dial in, just go to conferences on the left-hand side and you should see it. You can just click join if you have any questions. Otherwise, make sure you're ready by Friday. Your quiz on Friday is on 5.5, which is solving exponential and logarithmic equations, which is what we've been working on last week and this week. There are 10 questions. Most of them are multiple choice, but there are 2 or 3 where you just have to type in a numerical answer. And I will post an announcement on Friday with that. So please reach out if you're having any issues or need any help at all. Thanks, guys.